So question 20. So we have got y is equal to a sine, what is it? Omega. Then x upon v minus a. Okay, right. So now you know how to do it, correct or not? Yes. First of all, these two are in. These two are in what? Subtraction. Yes or no? Yes. Two things are in subtraction. Then what is same? Their dimensions are same. So what should I write? Dimensions of x upon v is equal to k. Clear? Yes. Sure? Yes. Okay, I'm glad my mistake helped you learn. So what is dimensions of k? Upon. So final answer. D raised to plus 1 or minus 1? Plus 1? Yes. Sure? Yes. Yeah. Don't make silly mathematical mistake. Okay? This is in the denominator. When you take it to the numerator, the power will change to negative, or it will be negative to positive, or vice versa. Clear? Yes. Everyone got there? Yes. Well. So that is dimensions of k. T raised to what? Well, let's go to 21. Right? 21. The time dependence of a physical quantity, time dependence means how P changes with T, time. Okay. So time dependence of a physical quantity P is given by P equal to P0 exp minus alpha T squared. Right. So in the 21st question we are given P equal to P0 exp minus alpha T squared. Now I know exp might be new to you, right? You might not have seen exp mentioned earlier, but exp actually means exponent. Exp is the another form of writing exponent. So what this means is as follows: P0 and then something raised to minus alpha T squared. Is that okay? Exponent means what you're writing in the power, yes or no? Yes. And now here we write E. Now you see this E is like nature's favorite number. In many equations in physics and in chemistry on its own, and when we try to understand what things are happening in nature, we make equations for them. And then when we get those equations, we find that this number E appears at so many places in in equations for physics and for chemistry. This E has a value 2.713 and then there are so many digits. Basically it's an irrational number. Like I'm sure you remember pi. Pi is something that comes on its own when you talk about area of circle or circumference of a circle and all that. Yes or no? Yes. So pi has value 3.15 and then there are many more digits. It's an irrational number. Just like that, E is also a number that comes up in many equations in nature. Understood what I say? Right? You are supposed to remember E's value. You should remember E's value, but there are infinite digits, don't have to go till there. Just remembering 2.71 is good enough. Just like in pi, you just remember pi is 3.14. Similarly, E is 2.71. Clear? We'll be using it time to time in different equations. So this is what P is given. P is equal to P0 e raised minus alpha. Right. Now what do we have? Let's come back to the question. What do we have to find? Constant. Dimensions of alpha. Is that clear? We have to find out what are the dimensions of alpha. Okay? Right? Look at alpha. Alpha is in the power of something, yes or no? Yes. But only alpha is not the power. Minus alpha T square is the power. What's the rule about powers for dimensions? Powers are dimensionless. Is that clear? Powers are dimensionless. Which rule is that? First. Yeah. Actually, the numbers are not important. I'm just asking you so that we can refer it easily. Okay? Even if you don't remember the number of the rule, don't worry. So, powers are dimensionless. That means alpha T square minus sign obviously does not have dimension. This has a dimension of m raised to 0, n raised to 0, t raised to 0. Raise your hand if you understood this. Okay, sure, powers are dimensions less. Fine. So we got this. So we want to find dimensions of alpha. Can you do the rest on your own? T for time, isn't it? Yes or no? It's given in the question that T is time. So find out dimensions of alpha. Raise your hand when you're done. Raise your hand when you're done. Okay, very good. Dimensions of alpha. Okay. Right. Yeah. Completed. Okay. Sigraj, what's your answer? T raised to. Who agrees with him? Who disagrees with him? Nobody disagrees? Well, he's right. There's no reason to disagree. Dimensions of alpha will be m raised to 0, n raised to 0, t raised to 0 divided by t square. Is that okay? Because time square. Okay, so that will give you t raised to minus 2. Understood? Yes. Which option? Okay. Have you understood in general how to solve such dimensions related questions? Yes. Okay. Well. Now, that was 21, right? Now time for 22. Okay. If force, length and time T are considered fundamental units or fundamental quantities, basically not units, correction is required with that, fundamental quantities. Right? So, suppose in some new system of units, it's not length, mass, time as fundamental units. What is fundamental? Force. What else? Length and time. These are the three fundamental quantities. Is that clear? These are the three fundamental quantities. So now whatever dimensional formulas you write, they should be in the form of force, length and time, not in the form of m, l and t. Did you understand? Yes. Understood? Dimensional formulas are always used to relate some derived quantity with the fundamental quantities. For example, if you want to relate velocity with length and time, we do it like this. Yes or no? Yes. Right? This is the dimensional formula of velocity. So similarly here, whose dimensional formula is to be found? Mass. Okay. Now is mass a derived quantity in SI unit? I mean SI system? No. In SI, mass is fundamental. Do you remember the 7 fundamental quantities? Yes. For SI. But this is not SI. This is a new kind of system. You understand what I'm saying? This is not SI. It is a new system where mass is not a fundamental quantity, but force is a fundamental quantity. Force is a fundamental quantity, length is a fundamental quantity, and time. We have to express mass in form of these. Question is clear? Question is clear or not? We have to express mass in form of all the things. So what we'll do is, there's no need to panic. This is a very simple question. Start with what we know. Do we know the routine dimensional formula of force? Yes or no? Yes. How many of you know that? Raise your hand. Routine dimensional formula of force. Okay, very good. And Nandini. Very good. Sit down. Okay. See, it is at these kind of situations where those formulas help. Right? If you don't remember, you'll have to derive it first. Without that, you cannot go ahead. So remembering increases your speed if you can remember. All right? Okay. अब the formula लखवानी तो कमाल है. इतना कुछ तो not तो अपने कोई नहीं याद न होता. I'm absolutely sure. Okay. Anyway, so we got this, right? This is dimensional formula of force. From here, we want to get to mass. So do you realize you can play with this a little bit? Can easily make dimensional formula for mass just by doing some division multiplication, something here. Yes or no? Yes. Yes or no? Yes. Do it. What will it be? I want the answer in form of F, L and T. I want what is mass in form of what? F, L and T. Okay? Clear? The question is clear? Do it. Just use a little bit of mathematical manipulation here. Yeah, very easy. Raise your hand when you are done. Okay, put it down. Raise your hand when you are done. Okay. Alright. Yeah. Yeah. Very good. Yeah, which one? Anything louder? Who agrees? Right. Well done. How do we get it? Simple. Divide length on that side, isn't it? So if you divide length, 1 upon L raised to 1 means L raised to minus 1. Clear or not clear? Divide time on that side. So that would be T raised to 2. Got it? Sure? Math is clear?
Yes.
I hope so. Okay, it's about the powers, isn't it? 1 upon x is x raised to minus 1. Do you know this?
Yes.
Similarly, 1 upon x raised to n is x raised to minus n. Do you know this?
Yes.
So that's what we are doing, right? When we get L in the denominator, that's what will happen. Okay, so this is going to be our answer. Find which option? Okay. Powers, everyone. Like I said, powers are very necessary for physics, right? At various places, you're going to have to do calculations related to power. You have to learn how to do that. Okay, 23. Ratio of the dimension of Planck's constant and that of moment of inertia is the dimension of which of the following? So first of all, there are some new kind of words for you. One is Planck's constant and the other is moment of inertia. What are these things? Let's. Planck's constant, first of all, comes from a relation like this. Okay, Planck's constant comes from a relation like this. H is the Planck's constant. H is the Planck's constant. E is the energy, and T is the time period. So from this you can find dimensions of H. The second thing that is given in that question is moment of inertia. Okay, generally moment of inertia symbol people use it as I. Okay, and the simplest formula for I is as follows: m into r squared, where m is mass and r is radius, or actually distance to be very frank. Now you might have a question, sir, how do we get all these formula? What do all these formula mean? Right now they mean nothing to you. And even if I try to explain, then also I will not be able to explain it successfully. Why? Because you still have a lot of physics to go ahead, and then only you will be able to understand what is the meaning of these. So like I said it earlier, in this chapter, I will not worry about the meanings of these quantities. Okay? Right now we'll just focus on dimensions. Clear? What is the meaning of these quantities? What are they used for? It will come at some stage in these 2 years. Somewhere or the other. Is that fine? Okay, so let's start. First thing that you have to do now for me is find out dimensions of H. Come on, hurry. Use this relation. Find out dimensions of H. Okay, I'm waiting for you. What are dimensions of H? You remember them? I hope not. Okay, you did it, right?
Yes.
Similarly, I want everyone to also find out dimensions of I using this equation. Raise your hand when you find both. Okay. Put it down. Once a few people do it, then we'll discuss the other, right? Okay. Okay. For this, once again, you need to know the dimensions of energy. Yes or no? has got the answer? Yes, Raghav. What is your answer for dimensions of H?
Sir, n raised to 1, n raised to 2, t raised to minus 1.
Repeat it.
M raised to 1, L raised to 2, t raised to minus 1.
Do you agree with him? If you agree, raise your hand. Who disagrees? अरे डिसएग्रीमेंट तो हो जाए ने तो ज आप कई डिस्कशन થાય ફટાકડા ફૂટે. Yes or no? If you will not disagree with others, then how will we discuss things? You would have got some answer or the other. If you have not got any answer, then that's not a good sign. કંઈક તો કરો. ખોટો આન્સર આવશે તો ખોટો આવે. આવા તો ખોટો આન્સર આવે. આન્સર તો કંઈક તો આવશે. What's your answer? Not for I, for H. M raised to 1, M raised to 2, E raised to 2. Do you agree with this, right? Okay. Is it that others are not raising hand because of hesitation or shyness? That shouldn't happen in this class. Or is it that you are not raising hand because you don't remember energy's dimensions? Is that the case? Okay, that means you need to work a little bit harder. Okay, try and remember the 10 basic ones. Okay, everyone, those who didn't do it. Well, dimensions of energy are m raised to 1, m raised to 1, sorry, 2, t raised to minus 2. And then we are multiplying this time here. Yes or no? So into t raised to 1. Clear?
Yes.
So what will be the answer? Exactly what he said. M raised to 1, m raised to 2, t raised to minus 1. See, if I wanted, I could have done this in a fraction of second on the board, isn't it? But I am asking you to do it because you have to give the exam, not me. If you will not practice it, you will not be able to do it in the exam, whatever that exam may be. Right? So we get this as dimensions of H. Similarly, here, raise your hand for this one now. Who has got it? Dimensions of moment of inertia. Dimensions of moment of inertia. Okay, come on, what's your answer? M raised to 1. M raised to 2. Who agrees? Who disagrees? બીજા બધા સુઈ ગયા છો કે શું? ઉઠો ઉઠો. Sit down. That's right. Mass. M raised to 1. Distance square. L raised to 2. Got it?
Yes.
Now what's the question? You have to take ratio of these two. Tough task or easy task?
Easy task.
Do it. Yeah. Got it? Let's see which option would be right. And then you have to try and match it with the options. Correct or not? After you divide or take the ratio of these dimensions. Right. So who claims some answer? A, B, C or D? Who claims some answer? Come on. Again, don't worry about right or wrong. Leave that to me. Okay. Okay, very good. Fine. What's your answer?
Type C.
Time. Okay. Stand. You say, you often speak without standing up. Okay, that's not what I like. Okay. Say it again. Time. Time. Option C. C. Who agrees? Who disagrees? Wait. Okay. Someone is disagreeing. Right? That's a good sign. That means somebody will have progress today. Whenever there is disagreement between people, you should understand that humanity will progress. Okay? Yes, Prisha, what is your opinion? What's your answer?
D.
D, that is frequency. What's your answer? D. What's your answer? D. Your answer is also D. Okay, interesting. Why are you saying it is D?
Because the dimension of frequency is t raised to minus 1.
Dimensions of frequency is t raised to minus 1. Have you got t raised to minus 1 or have you got t raised to 1?
T raised to 1.
You have got t raised to 1. Who else has got t raised to 1? Okay, who got t raised to minus 1? Okay, Sit down, everyone. So you see, it's possible that you are making variety of mistakes, right? So some of you, when you divide this, let's see what's the division first of all. When you divide this with this, so I'm just writing it over here, okay, as the ratio. So what will be the ratio? M raised to 1 e raised to minus 1 upon m raised to 1 n raised to 2. This is cancelled, yes or no?
Yes.
This is cancelled.
Yes.
So finally ratio is e raised to minus what? T raised to minus what? Not t raised to 1. Clear? Okay, so that's a calculation mistake. I'm sure you can correct it easily. Next step, right? Just be a little bit careful. Now others, those who said that these are dimensions of time. બરાબર પાણી વાણી છાટો ઉઠાડો પોતાને. What are dimensions of time? T. Only T, isn't it? Yes or no?
Yes.
Sure, you agree dimensions of time are T, not T raised to minus 1. So કેમ time કહેતા હતા? What is T raised to minus 1 for? Frequency. Yes, that is right. Okay, frequency. We don't have it in the list probably, but we would have derived it at some point of time. Or do you know that frequency is 1 upon time period? Do you know that frequency is 1 upon time period? So 1 upon time period, 1 upon time period. This is frequency. What do you think are the dimensions of this? T raised to minus 1. Clear or not?
Yes.
Sure?
Yes.
Okay. I'm just asking you casually. Do you remember that in 9th standard you would have studied about frequency? How many of you remember that? Oh, fine. Well then, let's go over to the next question. 24. If energy E is equal to G raised to P, H raised to Q, C raised to R, where G is the universal gravitational constant, H is the Planck constant, and C is the velocity of light, then the values of P, Q, and R are what? This question is similar to what we have done earlier. Only if you remember though. Let's check if you remember. We did something like time period of a pendulum is proportional to mass, length, and G. Do you remember something like this? No? Back when the classes were online, we did it. If you see it in your notebooks, you'll find it. I'm absolutely sure. You'll have this question. This is one of the examples from the book. Probably the last example. There, right? See, I am not asking you for anything more. I'm not saying that you start solving physics books on your own. But the bare minimum, whatever I am doing here, you do it along with me, and then you try to remember it. Is that clear? If I teach you something today and day after tomorrow you don't remember it, it's going to be your loss. There's no doubt about it. Physics is incremental. Without climbing the first step, you are not allowed to stand on the second step. Is that clear? Got it? Like I said, it's a continuous story. You miss out on few episodes, done, finished. Okay, then it will be very hard to catch up. Alright? So who will catch up with me now? Who will do things regularly? Raise your hand. Who is ready to do things regularly? Okay, I hope this hand up is not a formality. Remember this moment in your life, everyone, that you raise hand when I ask you who is going to study regularly as I teach you here. Okay. થાકી ગયા હાથ ઉપર રાખી લે કેટલી વારમાં થાકી જશો તો ફિઝિક્સ માં શું થશે put your hand down, don't worry, I'm just kidding. Let's start here. So this is actually a similar question. This is actually a similar question, but here energy is given. This is number what? 23, 24. Okay. E is given to be related with what? G raised to A. P P, yeah, okay. Not A, B, C, P, Q, R. And then H raised to Q and C raised to R. Okay, so some things are given here. E is of course energy, so there is nothing to worry about, right? We know its dimension, but we don't know G's dimensions. But let's attack the other one. H for Planck's constant. We already know the dimensions. Yes or no? Yes. M raised to 1, L raised to 2, P raised to minus 1. Clear or not? Yes. These are dimensions of H. We already know that. Fine. What about C? C is written as the velocity of light. Okay, now whether it's velocity of a truck or velocity of light or the velocity of a buffalo running towards you, it's all having the same dimensions of velocity. Okay, so what are dimensions of velocity? L raised to 1, T raised to minus 1. Is that clear? Yes. Sure? Yes. Well, so H and C. Right? But what about G that we don't know? Right? So whenever we don't know something, we try to find it out. Someone said something about G? Yes? E. You know about E. Everyone knows about E, right? Everyone remembers it by heart. Yes or no? Yes. Sure? Yes. Okay, so we know about E. We don't need your help. Alright? So, what about G though? This is capital G, which is universal gravitation constant. It is not small g, which is acceleration. So we'll have to find out. So here's a formula that involves capital G. Do you remember what this is called? What is it called? Newton's law of gravitation, right? This is the formula of gravitational force, which according to Newton is G into m1 m2 upon r squared. Clear? R for distance as usual. M1 and M2 are mass. Okay, of two different objects. And G is what we are after. So, just doing a little bit of maths, do you understand that G is equal to FR square upon M1 M2? Yes or no? Yes. Yes or no? Yes. Sure? Yes. Everyone got that? Yes. Okay. Find out dimensions of G yourselves. Come on. So that's the first step. Pachi to sam chalu thase. Okay. Find out dimensions of G yourselves, and then we can start. Without that, we can't. Yes, R means distance. R means distance. Done. Okay, very good. Very fast also. Well done. Okay. Right. It was a video no I can see that. Yes, Dia, what's your answer?
M raised to minus 1, L raised to 3, and B raised to minus 2.
Just M raised to minus 1.
L raised to 3, T raised to minus 2.
Who agrees with her? Who disagrees? No, she is not afraid of her. Yes, Hiral, what's your answer?
M raised to minus 2, L raised to 3, T raised to minus 2.
Okay. Any other answers? Anyone? Any other answers? Sit down, both of you. Let's see who's right. Okay. Asti, you have a different answer? What is the answer?
M raised to minus 1, L raised to minus 3, T raised to minus 2.
This is what you are saying?
Yes.
Okay. Anyone else got this answer? Okay. Fine. Let's force. Dimensions of force. M raised to 1, L raised to 1, T raised to minus 1. Distance squared. So L squared. Clear? Yes. Divided by mass into mass. So M raised to 2. Understood? Yes. Yes or no? Yes. Okay. Who spotted their mistake already? Who found their mistake? Raise your hand. Don't be afraid. Who spotted their mistake? Okay. Did you see what mistake you made? Yes. And okay, be careful with it next time. Alright? Okay, fine. Now what happens here? This is going to be M raised to 1 minus 2 means minus 1. Who's answer of this? Okay. L raised to 3. Okay. Clear or not? Okay. Why 3? 1, 2. Powers are to be added when you multiply. Yes or no? So 1 plus 2, 3. And now what's remaining? T. T raised to minus 2. So this is the final value of G's dimension. Let's put it here. Okay, sometime. Okay. Now, again, you see, you might be thinking, sir, it's going to take so much time. That's what you have to learn. You have to come from, it's going to take so much time to start. This is not worth doing on board. We will do it. You got what I am saying? You have to go from there to there. It's so tough to start, it's so easy. Don't do it, we'll do it. Right? Come on. So here we have to put all these in dimensional forms. Left side, E. Right side, G raised to P. P. So what's G? Yeah, M raised to minus 1, M raised to 3, E raised to minus 2, raised to P. Clear? Okay or not okay?
Yes.
Then multiplied with H. H that is M raised to 1, L raised to 2, T raised to minus 1, the whole raised to Q. And then multiplied with C. C dimension L raised to 1, T raised to minus 1, raised to R. Okay or not okay?
Yes.
Everyone. And we have to find which values. Read the options carefully. We have to find values of P, Q, and R. Okay. Now, some more uses of the rules of power. When you have something like this and then you have a power T, then it will become M raised to minus P, then L raised to 3P, then T raised to minus 2P. Okay, M raised to next Q, then L raised to 2Q. Okay, T raised to, then L raised to whatever. T raised to. Okay, so now we got this. Where take all the powers of M together. Because when you multiply, like I was telling you here, when you multiply two things with the same base, the powers are always added. So if you take M raised to this, M raised to this, and then we can add. So M raised to how much? M raised to how much? Minus P plus Q. Raise your hand if you understood this. When you multiply two things, the powers are added. Okay, put your hand down. This is, I've been explaining this many times now. It's very important that you learn this. This is what happens. A raised to x into a raised to y is equal to a raised to x plus y. So m raised to this into m raised to this is m raised to minus p plus 1. Okay, similarly, L raised to, who can tell me what should I write? L raised to, raise your hand. L raised to, okay, very good. Yes, here, what should we write? L raised to 5. Why 5? But there's P also, right? 2 also. I mean Q. So it will be 3P plus 2. Is that clear? We cannot add because there is P and plus R. Very okay. There is the third one. L raised to R. Clear? So 3P, 2Q and R. Fine. Okay, we'll try. Let's go to next one. T. Now who can tell me the power of T here? Who can tell me the power of T here? Similar process, right? Nothing new to do. Same idea. Yes, Millie.
P raised to minus 2P
Okay.
minus Q
Okay.
minus R.
Who agrees with her? Very good. Who disagrees? Sit down, please. That's right. Fine, so this is it. So now we are going to compare the powers on both sides. So first of all for M by comparison. What's on the left side for M? 1. On right side? Clear or not clear? Let's call this equation 1. Okay, second. For L now. For L. What should I write? 2 is equal to 3P plus 2Q plus R. Let's call that equation 2. Now for T. Okay, next. what do we get?
Minus
Minus 2 is equal to minus 2p minus 2 minus r. Clear? Sure?
Yes.
Okay, so that's equation. See, these look like linear equations. Do you remember linear equations? 2x plus 3y equal to this and 4x plus 5y equal to this, that kind of equations.
Yes.
But there's one thing. In 10th standard, you would have solved them with only two variables or two unknowns. For example, only x and y, not 3 x, y and z, not like that. But here there are three. Which three are unknowns? P, Q, and R. Okay, that doesn't mean you have to do something totally different. But yeah, it's a little bit long. Not as simple as it used to be for two variables. Let's keep it simple. There are three equations. Do you look at the first one? What's missing in the first one? R. So if I get one more equation without R, then I get two equations of P and Q. Yes or no? This is equation only of P and Q. Let's make one more equation of P and Q. Look at 2 and 3. Is there a way to kill R from there? Can you somehow remove R from 2 and 3? How? By adding, elimination. Yes or no? Okay, so if we add 2 and 3, I'm just writing it like this. Okay, equation 2 plus equation 3. Left side will become 0. Yes or no?
Yes.
Yes or no?
Yes.
No?
Yes.
Okay. 2 plus minus 2. How much is 2 plus minus 2?
0.
0. Clear or not clear?
Yes.
See, I teach you how to eliminate without writing that kind of table. I know you used to do that. This, then you add, and yeah, but no problem. Mind number your mind is very much capable. Have a look here. Just keep adding terms. So 2 and minus 2, how much? 0. 3p and minus 2p. P. Is that clear? 1p actually. Is that okay? 1p clear?
Yes.
2q minus q. Plus q minus q. Plus q. 2q minus 1q. 2 minus 1 is plus 1. Okay or not?
Yes.
And r minus r?
0.
Okay, that's right there. So this is, let's say, equation 4. Now, look at equation 1. 2 unknowns. Look at equation 4. 2 unknowns. Can you solve them? By elimination or substitution, whatever is your choice. For a solve. Do you remember you were given linear equation homework? Do you remember? હવે તમને ખબર પડે છે I am not a foolish man. કેમ homework આપ્યું તો સમજ પડી કે ન સમજ પડી? Because this is commonplace in physics. We will have to solve linear equations. So if you don't know how to solve linear equations, you are going to find it difficult. Done. All the three P, Q, and R. Find all the three P, Q, and R. So you can pick the correct option there. How many questions of linear equations are given? Probably 30 or something, if I'm not wrong. Or not? So I think I your phone master. Right? Come on everyone, you should be able to solve the equation. It's a requirement. टेंथ में जरूर पाछू जो जे टेंथ में पाछू लीनियर इक्वेशन सीखवा नहीं ने तो અહીંયા શીખી જાઓ 5 one step away. Yes, sir. What are you waiting? All the equations. If you don't try, you will never be able to do. સાયકલ ઉપર ચડ્યા વગર કોઈને સાયકલિંગ આવડે? આવડી જાય ને? તેનો આવડી જાય. There is called 1 with 4. Yes. 3 with 3. Done. Okay. Yep. Count all 3, right? Pick your nuts. Or not?
Yes.
Okay. Let me do it now. Let's hurry up, and I have a homework for you in mind. જરૂર છે બરાબર ને કે નથી જરૂર? I think you have understood what I'm going to give. So p plus q is 0 and this is the other equation. I'm just writing it here for you. Now you can use substitution or elimination as you may please. I'm going to add the equations once again. 1 and 4. Is that okay? That's called elimination. Why? Because if I add, what will be eliminated? P will be eliminated. Got it or not?
Yes.
Sure?
Yes.
So 0 plus 1
1.
equal to p minus p
0.
plus q plus q.
Q.
So we got q is equal to
1/2.
very good. Easy to do. Okay, not too easy. Easy to do ne? But it's as easy as watching Virat Kohli play cricket. હવે તમારો રમવાનો વારો આવશે. Got it? That's the difference. So q is half. What happened here and here? You can tell me, no problem. Then why were you hiding your solution? Sinta, was there any need to hide the solution? If you would have shown this and then you said, sir, now I don't know what to do, then I would have guided you. So q is half. Is that clear or not?
Yes.
Okay. If q is half, let's put it in any one of the equations here. I'm going to put it in 4. So by 4, 0 equal to p plus half. Yes or no?
Yes.
So what is p? What is p?
Minus 1/2.
Minus 1 by 2 or minus half. See, we got one more. Now it's time for r. So pick any equation which has r. You can try 2, you can try 3, whichever you want. I'm going to use 2. Okay, or by 2. By 2 and get nothing 3. So 2 is equal to 3. What's p? Minus 1 by 2 plus 2q. What's q? 1 by 2 and plus r. Okay, let's be very careful here. So 2 is equal to minus 3 by 2. Got it?
Yes.
Plus 1. 2 to cancel 1. Plus r. Got it? So r is equal to 2 plus 3 by 2 minus 1. Understood? 2 minus 1 is? 2 minus 1? 1. 1 plus 3 by 2. How much is 1 plus 3 by 2? 5 by 2 or 4 by 2? 5 by 2 or 4 by 2? 4 by 2 well up then. See the opening click that part. Okay, it is not 4 by 2. Come on people, don't do that mistake. You have to take n step first of all. So this is going to be 5 by 2. Is that clear? Yes or no?
Yes.
Sure?
Yes.
Which option?
A.
Now, what's your homework? Let me find what was given. I hope I'll be able to find it. Turn this off.